Hi friends. So here I'm going to draw the development of a square prism. The question is like this. A square prism of base 40 mm side and axis length 60 mm, 65 mm is resting on HP on its base with all the vertical faces being equally inclined to VP. It is cut by an inclined plane 60° to HP and perpendicular to VP and is passing through a point on the axis at a distance 15 mm from the top face. Draw the development of lower portion of the prism. So with respect to this question, I tried to draw the prism here, square prism. The vertical faces I made equally inclined to VP, equally inclined to VP, and a cutting plane I drawn approximately to 60°. So where the cutting plane is going to cut like this here. This vertical face is cutting at this point, at this point, at this point, like that. So in two-dimensional view, we are going to draw this one. So first we are starting with the top view and front view. Top view, front view I already drawn in order to reduce the length of the video here. Here we can see in the direction of 45° we need to use the rectangle command and we need to construct the square of 40 mm base side, this one like this. And respective front view I drawn with the axis height 65 mm. In the front view it appears like this. The visible vertical edges we are going to see here. So here the vertical edge coming from the A dash is this one, coming from the B dash is this one, C dash is this one, and from the D dash backside vertical edge will be there. So for this cutting plane we need to draw, which is passing through the axis from here, and the location of that cutting plane is 15 mm from the top surface. For that, let's take a reference line. I'm going to draw a reference line like this. Then a cutting plane I need to draw from this point. So before that, I need to set the distance from the top surface. It is 15 mm. Let's set this 15 mm from the top face. Now let's draw the cutting plane in this fashion. The angle we need to set 60°. So as this cutting plane is going to cut the entire prism here, simply we need to extend this one until this vertical edge is going to cut. Now locating the points here. While locating the points, we need to consider front view as well as top view. In the top view, the cutting plane, we have to consider from corner A, from this side, how the cutting plane is going to cut. We can say in anti-clockwise direction. So here the vertical edge coming from the corner A is going to cut at this particular point. For that simply we need to use the text command here, and I denote this particular point as 1 dash. Now 1 dash is cutting this vertical edge. Now the cutting plane is also cutting this vertical edge. In the front view, this line is going to cut. This line contains in fact the vertical edge coming from the B corner, coming from the D corner back side. So here first front side we need to consider. So after 1 I can denote here 2 dash. Next after that moving this side, so here the cutting plane is going to cut this line. So what is this line actually here? B to C, this vertical face is going to cut here. So here I denote 3 dash. Then so from back side also, the back side also we have DC or CD, we can say this vertical face. So this vertical face is also going to cut by this cutting plane. Here 4 dash I will denote. Then next this vertical line in fact contains two vertical edges coming from the B corner as a vertical edge and coming from the D corner, that is D dash vertical corner. So from the B vertical edge, coming from the vertical edge B, from the corner B we denoted 4. So back side one more vertical edge will be there. This one, this hidden line we can see here, this vertical edge is going to cut by the cutting plane. So that is why here number 5 dash I denote. So okay, that's all. So after this one we are going to do the development for this one, so that the development of the lower portion of the prism we are going to do. To do that one, parallel line method we are using simply. So for that, when this prism is unfolded, a plain sheet like structure where a rectangle we are getting in fact, so whose dimension is the multiple of the edge of this square prism, that is four edges are there in the sense 40 into 4 160 will be the length of the unfolded prism here. So for that what I will do, I will take reference first here like this. Then simply you can take the rectangle, draw a rectangle, set the length of that first one first initially, that is 160 multiple of 40 to 4 times. Now this rectangle we have to divide into these four vertical faces of the prism. How to do that one? Simply offset method you can use. In the offset, you have to select a single element, that is this single line, and offset length is 40. Then just go on clicking here. So like that, it is divided into four vertical faces. So for the movement, I drag this one here, and this is understood. Just you can remove this dimension line, not the dimension. Now over this one, from each point we need to project the lines here, parallel lines. So for that, again projection line I am using. So here number one, where it is exactly cutting, we need to zoom out that one, because it is not exactly to the corner, it is going to cut somewhat above from this, from the base of the prism. So start the line and draw the parallel line like this. Similarly, from the 2 dash, draw the line here like this. From 3 and 4 it is already there. Now we need to denote the corners. So for that I will take the text command here, and let's start from this one. This is my A, this is B, this is C, this is D, and this is back to A. That is from A to A unfolding is taking place. That is why. So these I will just reposition perfectly. Right. So now denoting the points here. So here over the what vertical edge coming from the A, that A dash point is there. So simply you can take the text command once again here. You can denote A dash here. This is what the A dash. So this A dash here also A dash will come, because A to A joining will be there, or opening from this A to A dash. Then 2 line is on what corner or on what edge, and from which corner it is coming. So starting from this side, from the B it is coming vertical edge. Over the B line, the 2 dash we need to denote, 2 dash. Then after that, so from B to C, from front side 3 dash is there. So for that what we need to do, so here we have to simply take the projection of this one, because in the front view it is in inclined position, we cannot get the true length, so that will be projected here like this. So this projection is on both the base edges, that is B to C, C to D, because B to C 3 dash is there, C to D 4 dash is there. So just project this one and measure this length. this length we need to measure. The same length will be here. Okay, let me measure itself for the sake of avoiding confusions. Okay, so we have the 3. So B to C, what is the distance? We have 12.25. So 12.25 B to C. Here the 3 dash line is this one. So what I will do, I will take arc by center point. So this B as center. So B as center, B to 3, what is the distance? We have 12.25. 12.25 and enter, cut that one. Okay. So this is the point where we can denote this one as 3 dash. Next, here after that C to D we come across the 4 dash point here, C to D. So we measure the distance from D to C. So for that what I will do, the same distance from D to C I will measure, that is 12.25 and cut this one. And this is the point number 4 dash. Now 5 dash is exactly on the D, because 5 is coming on backside uh, edge, that edge is coming from backside point D. So 5 we have to denote here, 5 dash. So in fact you can measure these distances and you can show also like this. To avoid confusions you can do like this. Next I will zoom out this area and try to set the points exactly where they are. This is 1 is perfect, 2 is here, 3 is, let me make it closer, 4 is here, 5 is here, so 1 is here. So here simply we can take the construction or visible line. So all the points I will connect in the zoom position only. So 1 to 1 dash to 2 dash, 2 dash to 3 dash, 3 dash to 4 dash, 4 dash to 5 dash, 5 dash to 1 dash. Then the below portion I am connecting, because I need to highlight the lower portion of the prism. So this is the cut portion, this is the below portion, and here these lines also we need to highlight to complete the projection here. This is vertical edge. So this vertical edge is cutting at 2 point, and this is need not, this is the plane surface, vertical face is coming here. Once again you have to connect. So this is what all about the development here. Now let me write the development. So here I will write yeah. So that's it guys, this is the solution how we can proceed this one. This is a very simple problem. I given a imaginary view also to imagine you people how the cutting plane is going to cut at 60° to this cutting plane. I hope this video helpful for you to understand the parallel line projection, parallel line development of the square prism. If you like this video, do subscribe the channel, share, and if you have any doubts, any comments, put in the comment box. Thank you.